In this video, we're going to go ahead and practice solving some linear equation mixed application word problems together. Now, to be able to do these types of problems, hopefully you've already learned a little bit about slope-intercept form, point-slope form, and standard form. And in order to get the most out of this video, I encourage you to grab some paper and something to write with so we can go ahead and do some math together. All right, let's get started. For number one, Ronan initially has $40, and then each day he's going to be spending $2.50 on candy. We're going to go ahead and write an equation to represent how much money that he has left. Let's just start with that first, and then we'll deal with the next few questions after that. To start, it's always good to define our variables. So time is our independent variable, so that's going to go along the x-axis, that's going to be the number of days. And y is going to represent the amount of money that he has left. This is dependent on how much time goes by. Now, a couple things to notice right from the beginning here is that we initially had $40, so that's going to be a b value, or the y-intercept, right? The word initial lets us know that's what we're starting with. The second thing I think is really important is that we know that he's spending $2.50 per day, so that is a unit rate because it's the amount of money he's spending per one day. So that's m, or the slope, and it's going to be negative 2.5 because he's spending money, so he's going to have less and less money over time. So that's going to be the slope. So if we already know the y-intercept and the slope, I think the best thing to do is to go into slope-intercept form. So remember, that's going to be this y is equal to mx plus b. And substituting in here, we're going to get y is going to be equal to negative 2.5 times x plus that starting amount, which is going to be 40. All right, so when the direction said to write an equation, that's this right here, so that part is done. For this next part, we're asked how much money is Ronan going to have after 11.5 days have gone by, or 11.5 days. Now remember, the number of days here, this is going to be an x value, just because x is time. So let's go ahead and just plug in 11.5 in for this x value here to figure out y, which is how much money he's going to have left. All right, so if x is 11.5, we're going to get y is equal to this negative 2.5. That's $2.50 he's spending per day. We're going to go ahead and multiply that by the 11.5 days, or 11.5, and go ahead and add on that $40 that he was starting with. All right, so he's spending $2.50 per day for 11.5 days. If we go ahead and multiply those two together, we're going to get another negative value here. So the amount of money he has left is going to be equal to, it's going to be negative 28.75. So he's spending $28.75, plus he has the $40 that he initially had. And then finally, if we just go ahead and add these two together, we're going to see that after he spent $28.75, he's going to have $11.25 left. So after 11.5 days, we know that Ronan's going to have $11.25 left. Now, the last part of this problem is pretty interesting. The question is how many days go by? So they're asking us for the number of days. So we're going to solve for x. It says how many days go by when Ronan runs out of money. So when Ronan's going to be running out of money, how much money does he have? That's going to mean that y is going to equal 0 because y represents how much money he has left. So let's go ahead and substitute in y equals 0 into our equation and then solve for x so we can find out when he runs out of money. And so if y is equal to 0, then we'll substitute in 0 in for y and say if there's $0 left, how long would that take? So 0 is equal to that negative 2.5 per day. We don't know how many days they're going to go by before we run out. And then plus that $40 here. All right, we're going to go ahead and take away 40 from both sides. If we do that, we'll get negative 40 on the left side is equal to negative 2.5 x. And then we go ahead and divide both sides by negative 2.5. I know 5 times 8 is 40, so 2.5 is half of 5. So if we divide this, this should equal 16. So basically, to have no money left, it's going to take 16 days if Ronan is spending $2.50 per day. All right, here's number 2. In number 2, a food truck is selling a special drink and a special food item today. In a given day, the food truck made a total of $90 from selling these two items. The drink item was sold for $2.25 each, and then the food items were sold for $4.50 each. Now, this is a classic example of when you would want to use standard form, just because we have a total amount of money that was made, and then we have two different items here that we're selling, and we know the cost of each of them. So before we write our equation in standard form, let's go ahead and define our variables. I'm going to go ahead and let x represent the number of drinks sold, and let y represent the number of food items sold. All right, now let's go ahead and write our equation in standard form. So for the drinks, we're selling them for $2.25. So how much money are we going to be making off those? Well, it's going to be $2.25 times how many of those drinks we sell, plus what? We're selling these food items, so those are going to be $4.50 each. I'm just going to write 4.5 here. That's going to be multiplied by how many of these food items are sold, so multiplied by y. And then if you add up how much money they make from both of these, that's going to equal the total amount of money they're making, which is $90. So when it says to write an equation that represents the total sales, that is what this is. This represents the total sales, and it's a linear equation just written in standard form. All right, next we're asked a hypothetical of if they sell 16 of these drink items. Now, the drinks are going to be X. So for the 16 here, let's go ahead and plug in 16 in for X. They want us to find out how many food items they're going to sell. Food items is going to be Y, so we're going to be solving for this Y value. And so substituting in, we are selling each of these drinks for $2.25. Let's go ahead and multiply that by 16 since we're selling 16 of them here. So we want to figure out the total amount they make from that. Plus we have this $4.50 per each of these food items. We're going to solve for that in just a moment. So 4.5y, and that's still equal to the total cost of $90 that they're making. Now, if we go ahead and multiply 2.25 times 16, that should be 36. So this is going to be $36 here, plus this 4.5y, that's going to equal 90. Next, if we go ahead and take away 36 from both sides, we're going to get $4.50 per each of these food items. We made $36 from the drinks, so take that away from 90, that's going to be $54 they must have made from just selling the food items. And if you take that 54 and you divide that by 4.5, which is the cost of each of the food items, we're going to get that y is equal to 12. And so if X is equal to 16, or we're selling 16 of these drink items, then we know that we're going to be selling 12 of these food items if we're making a total of $90. All right, for this last question, it's asking what if we only are selling drink items, or we're only selling these food items? How much of each of these are we selling? Now, if we're only selling these drink items, then that means we're not selling any of the food items. So if we're only selling drink items, then that means that the food items y has to equal 0, right? So let's go ahead and figure out x if y is equal to 0, or we're not selling any food items at all. All right, so if we're only going to be buying drinks, that means y is going to be 0. So if this 0 multiplied by 4.5, that's going to cancel out. So we're just going to be left with 2.25x is equal to 90. So if we go ahead and write that down, that's going to be 2.25 multiplied by x, and that's going to equal 90. Now, hopefully this equation makes sense because it's letting us know that all the profit is coming from just drinks because we bought 0 of those food items. So if you divide both sides by 225, the cost of one drink, we should get that x here is going to be equal to 40. So that lets us know that we are selling 40 of these drinks to make $90 total. So we just found out if y was equal to 0, then x is 40. So we could say 40 comma 0 would be a point on the coordinate plane. All right, so if they made $90 from just selling drinks, they would have to sell 40 drinks. All right, similarly, if they're making all of their money from just selling food, if they're just selling food, that means that x must be 0 because they're not selling any drinks. So 0 times 2.25 would just be 0. So we're just gonna be left with 4.5y is equal to 90. So let's go ahead and write that down. We're gonna have 4.5 multiplied by y, 4.5y, and that's going to be equal to 90. So this is just saying that all of their profits are just coming from food because they didn't sell any drinks. So this is going to be our equation. Now, if you go ahead and just take this 90 and you divide that by 4.5, the cost of each food item, then you're going to find out here that y is going to be equal to 20. So if you're looking at that as an ordered pair, we just said basically if x was 0, or we bought 0 of these drinks, then you would have to be selling 20 of these food items to make that $90. And so if they made $90 from just selling food, they must have sold 20 of those food items. All right, let's check out a third example. In number 3, Julia is saving up to buy a new video game. Looks like that on week 5, Julia has $78 in her bank account. And also that Julia receives $8.50 per week for allowance. We're going to start by writing an equation to represent the total amount of money that Julia has, but let's first go ahead and define the variables. Let's go ahead and let x represent time, or the number of weeks that go by. And let's let y represent the total amount of money that she has in her bank account. When we're told that in week 5, Julia has $78, that's actually a point that we can go ahead and write down. So in week 5, now time is going to be x, so it's going to be 5 comma, then she's going to have $78, which is y. That's going to be representing how much money she has. That's going to be a point on our graph or in our equation. Now, another important thing to notice here is that we're also told how much she is making per week. So that's actually going to be the slope here. So she's making more money per week. So we know that M, or the slope here, is going to be a positive 8.5. So she's making $8.50 every week. So if we are given a point and we're given a slope, I think the thing that makes sense to do here the most is to use point slope form. So for point slope form, we're just going to go ahead and write y minus y1 here is going to be 78. And then we're going to go ahead and say that's equal to M. In this case, M is going to be 8.5 multiplied by the quantity of x minus x1. So x minus, in this case, we know that it's going to be $78 in week 5. So that x and y are going to be 5 and 78 here. And so if you're asked to write a linear equation with a point and a slope, then point slope form is going to be the most efficient way to go ahead and do that. For the next part of the question, we're asked how much money Julia is going to initially have. So this word initially here is pretty important. You could find out the b value if you are in y equals mx plus b form, or the slope-intercept form, but you can also find out how much she initially had, which is when time is 0. So for initial, then the time must be 0. So if we say x is equal to 0, then we can go ahead and solve for y. So let's go ahead and just do that and change this x to 0 and then solve for y here. That's going to be telling us how much money she has, which is y, when we are talking about the initial time, or when x is 0. All right, so substituting in, we're going to get y minus the 78. That's going to be equal to 8.5, how much money she's making per week, multiplied by what? Well, it's going to be 0, because we're talking about time equals 0, so it's 0 minus this 5 here. All right, so let's solve for y. 0 minus 5, that's just going to be negative 5, so I'll go y minus the 78. That's going to be equal to 8.5 times negative 5. Then if we go ahead and multiply 8.5 times this negative 5, we're going to get y minus 78. That's going to be equal to negative 42.5. And then if we add 78 to both sides, we're going to get y is equal to 35.5. And so this just tells us that before she started keeping track of how much she had to save for this video game, that she already had $35.50 saved up. All right, now for this last part of the question says how many weeks? So that's going to be asking for X, right? So we don't know what that's going to be. She is going to have to save up for if the video game costs $2.05. So this is going to be a Y value because that's going to be how much money. So we're going to be solving for X and we know what Y is. So let's take this 205 and let's plug that in to our equation right over here and say that Y will be 205. And then we can solve for X, which is going to be how many weeks go by until she'll have enough money to buy that game. So if y is 205, or that's the total amount of money she needs for that game, we're going to say 205 minus the 78. That's going to be equal to, let's see, we have 8.5. She's making $8.50 per week. And then we're going to go ahead and multiply that by x minus this 5, because we know that at week 5 she has that $78. So we're using that point that we had earlier. Now, if we go ahead and take away 78 from 205, that's going to be 127. So on the left side, we're going to have 127. That's going to be equal to this 8.5 multiplied by x minus 5. So on the left side, we're going to have 127. And on the right side, 8.5 times x is 8.5x. And then 8.5 times this 5 is going to be this negative 42.5 or minus 42.5. Now, if we go ahead and solve this two-step equation, we can add 42.5 to both sides. If we do that, we're going to get 169.5 on the left side, and that's equal to 8.5x on the right side. Now, finally, if we divide both sides by 8.5, we're going to find out that x here is going to be approximately equal to 19.94, just rounding to the nearest hundredths place, right? So it's going to be approximate here. Now the question here is, should we round up or should we round down? Now, if we round down to just 19 weeks here, you're going to see that she's not going to have enough money for this 205. So it's basically saying this is close to 20 weeks, right? So it's better to save for a little bit longer than a little less to make sure she has enough money. And so hopefully it makes sense here. We should round this up here to say she needs to save for 20 weeks so that she has $205 to buy this game. All right, here's one more practice problem here. In this problem, the value of Layla's bank account changes at a constant rate. Now, if we know it's changing at a constant rate, that means we're talking about a linear equation, so that slope is going to be involved. We're told that in month 16, she has $72, so I'm just going to go ahead and write that as a point. 16 is going to be time, and it's going to be $72. That's going to be our Y value. So that's going to be a point that we know. Now we're also told that on month 27, she has $154.50. So I'm going to actually write down another point that X is going to be 27 for 27 months. And then she's going to have $154.50. That's going to be our Y value here. So we're given these 2 points, and we're going to go ahead and write a linear equation that represents how much money she has in her account. Of course, it's always good to define our variables first. So we're going to let X represent time, which is the number of months, and let Y represent the amount of money that she has in the bank. All right, so remember that we have these 2 points and we're going to try to write a linear equation. I think it's going to be a good idea to use these 2 points to find the slope. So to find slope, or m, that's going to be equal to the change of y over the change of x. Now I'm just going to go ahead and call this my y2 minus y1. So I'm going to go from the bigger number minus a smaller number here. So I'm going to write 154.5. Let's go ahead and take away the 72. So it's going to be a y value minus a y value. Let's go ahead and divide this, or find that between the ratio of the change of y to change of x. So let's go ahead and do 27 minus the 16 here. So that's going to be the change of x here. So 27 minus that 16. All right, now let's go ahead and simplify this a bit. So on top, 154.5 minus 72, that's going to be $82.50, or 82.5. So we know we're changing, the account's changing by $82.50 per, and it's how many of these months? Well, 27 minus 16, we know it's going to be changing in 11 months there. All right, now we can simplify this a little bit further. So if it's changing $82.50 in 11 months, how much is it changing per 1 month? So 82.5 divided by that 11 is going to be 7.5, right? This really just means her account is changing by $7.50 per 1 month. All right, at this point we have a slope, and we actually have 2 points. So we have this point and another point. If we're going to go ahead and write a linear equation here, I think the easiest thing, or most straightforward thing to do, is to just use point slope form again. Feel free to use another form if you would like to, but I think this is going to be the most efficient way. So I'm going to use point slope form, and I'm actually going to use this point here because these numbers are smaller and there are no decimals. So for point slope form, we're going to do y minus. Now y1 here is going to be 72. That's going to be equal to m, which is 7.5. That's going to be our unit rate. That's going to be multiplied by x minus whatever x1 is. x1 here happens to be 16. So we knew that at month 16, we had $72. So this right here would be our linear equation. Now the next part of this question, we can go ahead and use this linear equation. We are going to go ahead and determine the initial balance of her account. So initial balance, that's going to be how much money she had in the beginning. So that means that x is going to equal 0. And we're going to figure out how much she had before she started saving money here. So let's go ahead and take x equals 0 and plug that into our linear equation. And we can figure out how much money, or y, she has when we started. So if x equals 0, or we're talking about the initial balance, let's go ahead and plug that in. We're going to get y minus the 72. That's going to be equal to, let's see, she's making $7.50 per month, multiplied by, let's go ahead and plug in 0 here in for x. So we're talking about the initial time, x minus the 16. All right, we can go ahead and just start solving this, solving for y. So 0 minus 16, that's going to be negative 16. So we have y minus the 72. That's going to be equal to 7.5 multiplied by negative 16. Now 7.5 times this negative 16 here is going to equal negative 120. So we're going to write y minus 72 is equal to this negative 120. Finally, if we go ahead and add 72 to both sides, we're going to get that y is equal to negative 48. So what does this mean? This just means that when x was 0, or when before she started keeping track in the scenario, that her bank account must have been at negative $48 before she started accumulating more and more money over time. So she was in debt to start with. And finally, there's one more part to this question. It says how many months go by when she has $514.50 in her account. And so this $514.50, that is going to be a y value. So when it says how many months, that means we don't know x. So we're going to be solving for how many months, which is going to be our x. So let's go and take this 514.5. Let's go and take that value here, and let's plug it into our y value, which is right over here, so that we can solve for x, which is how long it'll take to get that much money in her account. So if y is going to be 514.5, let's go ahead and plug that into our equation. So 514.5 minus the $72 minus 72. That's going to be equal to 7.5 multiplied by the quantity of this x minus the 16. Now if we subtract 514.5 minus the 72 on the left side here, we're going to get 442.5. And then on the right side, we can go ahead and distribute the 7.5 to both of these terms over here. So 7.5 times x is just going to be 7.5x. And then 7.5 times that negative 16 is going to be negative 120. So we can write minus 120. Next, let's go ahead and solve this two-step equation by adding 120 to both sides. If we do that, we're going to get 562.5 on the left side. That's equal to just 7.5x on the right side. And if we go ahead and divide both sides by 7.5 now, we're going to get that x is going to be equal to 75. So if y was equal to $514.50, so the total amount of money that she has in her account, it must have taken 75 months to get to that point. Alrighty, so there you have 4 different practice problems on dealing with some linear equations applications. Each of them had a few different parts to them to make them a little bit more complex and help you understand how to use these linear equations a little bit more effectively and on a deeper level. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.